So we are talking about quadratic functions. If you're following the textbook, then we are talking about section 3.3. If you're not following the textbook, then don't worry about it. So we just want to look at one other type of function to show that not everything is a straight line. As soon as we get to things more complicated, we want a curve to have some sort of bend in it, to cover something more general. So we're just looking at one other one that generalizes, is a step further from the linear function. So we're looking at functions of the form f of x equals a times x squared plus b times x plus c. That's what I want to look at. And it's not unfamiliar. I'm sure we've seen quadratic functions before, but it's worth just remembering that not everything is a linear function. Not everything is a straight line. If I remove this first term, then I have my straight line, my linear function. If I have this guy as well, then I have something slightly more general. So I'm not going to derive all the properties from scratch and things like that. I'm just going to mention it and then we can use it. There's a difference between what we're trying to do and what Math 12 or pre-calculus wants to do. We're just going to use this to get to more relevant, more practical problems. So what does this function's curve look like? If I have a greater than 0, then it has the following shape. Parabola and it's pointing up. In my xy plane, if I have a less than 0, then I have the following shape. Parabola pointing down. So it has some bend in it when I bring in this x squared term. Not just a straight line, this guy makes it bend a little bit. Has anyone seen this parabolas? Not at all?
In high school.
Long time ago.
No, like 2 months ago.
So depending on your memory / age, this might be familiar or not, it doesn't really matter. The point is I have a slightly more general function, and this is what it looks like. So we're skipping some stuff. We're skipping why does it look like this? Why? We don't care, we just want to use it. So when I look at this parabola, there is a point here at the very bottom. So the y value, as I go from left to right, the y value goes down, and then at some point it turns and goes back up. So I have a minimum value, a minimum y value here. My minimum point. What about this one? Here, if I go from left to right, the y value increases up to a point, and then it goes down. So I have a maximum here. So depending on what this a, these are values, a, b, and c. Depending on what a is, if a is positive, then I'll have a minimum y value. If a is negative, I'll have a maximum. So that a tells me something about the curve, and it's very different depending on the value of a. Now, the x value, where this minimum and this maximum occurs, that depends on these a, b's, and c's. How does it depend? This is just something I have to remember. This x value is given by negative b over 2a. Negative b over 2a. So we're skipping deriving this. I can prove to you why it's like that, but it's going to take an hour and I don't want one. whether it's a maximum or a minimum, this x value is the same. Negative b over 2a. So I just remember it. It's the only thing I have to remember. Negative b over 2a. It's not an asymptote. We call this line the axis of symmetry, because it cuts this curve in half. It's a mirror image. Axis of symmetry. So the good thing is that whether it's a minimum or a maximum, the x value where that happens is always the same. I just have to remember minus b over 2a. Now, how do I find the corresponding y value? Well, this is my function. So if I have an x value, I have the input. How do I find the y value, the output? I just plug it in. So the corresponding y value, I just plug in to the function. I don't have to remember anything else. I just plug it in. So f of whatever this value, negative b over 2a is, that gives me the y value. Any questions on the parabola? When it's pointing up, when it's pointing down, axis of symmetry, minimum, maximum. Any questions? If you're not familiar with it, we just have to remember a few things. So it's just a different function that we're going to use. It's not a straight line. The more bendy the function, the more bendy the curve, the more things it can describe. Bendy, technical term. So this is the type of function that we want to look at, and we'll quickly see that the types of questions are the same over and over. Just to be sure we can sketch these before we get to word problems, I want to just look at an example or two where we just make up the function. Negative x squared minus 4x plus 12. It's made up, doesn't come from anywhere. I just want to practice. Yes?
What is f for x negative b? Is it the one on the y? Yes.
This is the y value that corresponds to this x value.
Is it the y and the curve?
It is the y value, the y coordinate of this point. There's this special point, the maximum. This is its x coordinate. This is its y coordinate. Once I have the x coordinate, I just plug it into the function and it gives me the y value, the output. Input, output. Input, output. So now I just have this function. It's coming from out of thin air. What are my steps to sketch this curve and find where this minimum or maximum occurs? First thing, I want to look at the shape. This, well, let me backtrack. Let me just say that for this function, what is the value of a, b, and c? A is -1, b is -4, c is 12. First thing I do is try and determine the shape. Well, a is negative. A is less than 0. That means that I'll have a parabola pointing down. So what do I have? A maximum or a minimum? Maximum. Next step is, where does this maximum occur? So I want to find the axis of symmetry. That gives me the x value where the maximum in this case occurs. So axis of symmetry is when x is equal to -b over 2a which is negative 4 over 2 times negative 1. So x is equal to, that's a 4 over negative 2, looks like negative 2. What is the corresponding y value? Well, I plug in my x value into the function, and it gives me a y value. What is the y value that I get? What does the calculator say? When I plug in x equal to negative 2, what is the output? There's my function. X is the input. This is how I get the output. X equals negative 2. Hey?
Sorry.
Is everyone happy with this negative 2?
16. Yeah, that's 16.
16? Can anyone confirm is 16?
Yes.
4 minus
16? So when x is equal to negative 2, y is equal to 16. So there's my maximum. And my parabola goes down in some sort of parabola shape. How would I find this y-intercept? I'll just do it once and then we'll move on. How do I find the y-intercept? What do I set? What do I do? Set y equal. How do I find the y-intercept?
Connect close.
We're on a straight line. It's not a straight line.
X equals 0.
X equals 0.
Can't you just use that C?
Yes, I want to show that it's just that C value.
Yeah.
Yeah. It's always just a C value. Now, it doesn't come up a lot, but it's good to be aware of. Because when I set x equal to 0, everything falls away except C. And y is going to be equal to C. What about the x-intercepts? I'll just do it once. Now I set y equal to 0. What do I get? Negative x squared minus 4x plus 12 equals 0. How do I solve that? Well, I have some choice. I can use the quadratic formula if I really don't want to do anything else. But I always do a little check. Let's just see if I can factor it, because then it's going to be much faster than the quadratic formula. If I can't see it right away, the quadratic formula is always there to help me solve this. I don't like this negative. So let's multiply with a negative 1 throughout to get x squared plus 4x minus 12 equals 0. That one looks much nicer. Much nicer. Can I factor that? So I'm looking for factors of 12 such that the difference is 4. 6 and 2. What are the signs? Different signs. The biggest one gets a plus. And you can always check it. FOIL them out, multiply them out, see if I get my previous equation, then I did it correctly. So I could say that x plus 6 is equal to 0, or x minus 2 is equal to 0. So x is equal to negative 6, or x is equal to 2. So this guy is negative 6 and 2. So yes, we're placing an emphasis on the maximum and minimum point. That's usually what I'm interested in. But I can find the x and y intercepts reasonably easily. Because if I can't factor it, I have the quadratic formula. Either way, I can do it. Any questions on this? I don't want to go too fast. When we look at a quiz or a test question, things like that, I try and go towards what we're here to figure out, which is answering more practical problems. So I try and stay away from just giving you a random function for no reason. I'm rather interested in getting a word problem and using that and interpreting my answer, things like that. So I can't say this isn't in a quiz or it is, but this isn't the emphasis. We're using these things in our word problems, but we need to look at them first. Okay, here's my next function, I think. Yes. So x, y, p, q, whatever. Doesn't matter. Here's my quadratic function. Is it a quadratic function? What is a, b, and c?
A is 2. B is 0. And C is 0.
So this still fits, even though it looks much nicer, it still fits the quadratic function. So what is the shape? Well, A is positive, so that means that I have a parabola pointing up, so I have a minimum point. What is that minimum point? Well, I have to look at the axis of symmetry. Axis of symmetry, negative b over 2a. So there's a little bit to remember, unfortunately. I have to remember this negative b over 2a. I don't have an x, I have a q. Negative b over 2a is equal to, oh, what is this equal to? 0, because b is 0. So as soon as I don't have all the terms here in my quadratic function, things are going to be much simpler. It's not as difficult as it could be in general. Let's sketch it over here. So my axis of symmetry is this p-axis. What is the corresponding p-value? P is equal to, when I plug in q equal to 0, p is equal to 0. So this point over here, 0, 0, is my minimum point. So there isn't much to say. I just have a parabola like this. But it still fits the general quadratic function form. Let's do one more just to be sure.
Are we not finding it for the?
There are no intercepts. It's so simple. It's not much to do. I just want to, with this example, just want to show that it does still fit the general function, even though some of the values, well, because some of the values are 0, it just reduces it much simpler. So there isn't much to do there. The next one is G x squared minus, I have a terrible memory, 6x plus 7. Just to make sure we know how to find the maximum or minimum and do a rough sketch. It doesn't have to be a perfect sketch. A is equal to 1, B is equal to -6, c is equal to 7. So I just do that for my own sake because the axis of symmetry is easier if I can just read it off. The first thing is the shape. Well, A is positive, so that means I have a parabola pointing up, and I'll have a minimum for my function. Then the axis of symmetry axis of symmetry is when x is equal to what is x equal to? What's the formula? Then I plug everything in. I get negative 6 over 2 times 1. Looks like it's 3. The one thing I have to remember, negative b over 2a. So let's get a sketch here and update it as we go. I know something happens at 3. What is the minimum value? Well, I just plug it in. My input is 3. What is my output?
Minus 2.
Minus 2. Anyone confirm his minus 2? So something happens here below negative 2. There's my minimum value. What is the y-intercept? I have a slight problem here. I don't know if it passes the x-axis there or there. Which side of the y-axis do I cross the x-axis? This one or this one? How do I know that? What is the y-intercept? So you said? 7. So that means I have to, let's say 7's up here. I have to go through this point. If I take the left route, can I go through this point? No, so it has to be this one. Something like that. Doesn't have to be perfect. Something like that. The key thing is this minimum. And what is the minimum function value? Any questions on this? Any questions? Yes.
Why isn't it go from the 3? Isn't that what happens?
Sorry, say again.
When you draw the thing, doesn't it go from the 3? Isn't that what axis of symmetry is?
The 3 is where the axis of symmetry is, yes. It's the x value where this line is. I have to find the corresponding y value to know where on this dashed line does my minimum value sit. And it sits where the y value is negative 2, so it sits below here.
Okay.
You're not happy with that?
I'm just a little confused.
So the axis of symmetry is where I split this parabola in 2. The x value is given by negative b over 2a. So I plug it in, I get a 3. So I know where this line is sitting. It's over here, where x is equal to 3. So I have a minimum value somewhere on this line. But where is it? Does it sit up here? Where is it? I have to find the y value that corresponds to 3, to x equal to 3. How do I do that? That's the output when my input is 3. I get negative 2 based on my function. So that means when x is equal to 3, y is equal to negative 2. So it sits over here. And because it's a minimum, then I go up from this point. So I need both to tell me where this point sits. Not just the x one. I don't know where I sit. I need the corresponding y coordinate. Okay.